Hey, good morning. All right, so today we're going to wrap up polynomials of factoring. So again, we can't forget how to multiply polynomials, how to add and subtract them, how to put them in order. But today we're going to just kind of focus on wrapping up factoring. All right, so when you do the warm-up today, number one, I want to help you with. So don't worry about number one, but do numbers 2, 3, 4, 5. And then we'll come back and talk about number one. Okay. All right. Well, let's talk about number one here real quick. We kind of are skipping over this a little bit, but not really. We've done reducing, but what I would like for it to do is to factor that guy right there, if you would. So, in other words, what's the greatest number that goes into 12 and 18? Would you agree that it is a 6? So we pull out a 6 and we can pull out a y to the third. So now what's left? We have 2 y's, because y would give me back to the fourth, and we have a minus 3. Okay, now let's go down to the bottom. If I asked you to factor that guy, what would be the greatest factor that goes into, common factor goes into 28 and 42? If you're saying 14, that would be correct. So I can also pull out a y, and then what is left? I have a 2y, give me back to 28y squared, and a minus 3. Now look what happens here. Sometimes when you factor things out, this happens that 2y over 3 will cancel out with the 2y over 3. Okay, so now let's go to reducing. Is there a number that goes into 6 and 14? This is the part we've done before. Yeah, 2 does. 2 goes into 6 3 times. 2 goes into 14 7 times. Now let's focus on my y's. One of these y's would cancel out with one of these up here and just leave me with a y squared up there. So that whole complicated thing comes down to just a y, 3y squared over 7. Okay? All right, let's see how you did on the other ones. I agree this takes a lot of work, but if you practice making that x, finding those, common numbers, that speeds things up. Down here on number 4, I don't know, did you use what we learned yesterday, a perfect square? I looked at and right before I even started factoring it, and I said, hey, that's a perfect square. Now you might have factored out some numbers I might have factored out a 2x. No, just a 2 we could have factored out all the way across. No, because 2 doesn't go into 49. All right, so let's see. If you just factored it using the x method, you'd probably still come up with the same thing, okay? But you should have had two of them, a 2x plus 7 times a 2x plus 7, which yesterday we talked about is a 2x plus 7 squared. Over here on 5, I took out a 3 right away. And then yesterday, we did difference of a perfect square. And so one of them would be a plus 3 and one's a minus 3. My middle terms go away. And so that's kind of what we learned yesterday as well, okay? So today we're going to combine everything that we've learned so far, okay? So we're going to kind of do this whole steps here. First of all, we want to kind of see if there's anything that can be factored here. They already factored out a 2x, and they want to know, did we factor it? Are we done? And so kind of I'm looking at this one, and I want to think about, is that a perfect square? If I did an x times an x, can I get a 4 and my middle terms go away with both of these being a positive? Well, if I did two negatives, that would be a positive 4, but I'd have a minus 4x in the middle if I did FOIL. If I made one of them a positive and one a negative so that they cancel out, well, then I want to get a positive 4 when I did FOIL. So again, I'm envisioning FOIL here. I have a minus 2x plus 2x and a minus 4, but now I have my x's gone away that I don't have a middle term, but I have a minus 4. So I believe this one is completely factored. But before we write completely factored, we should make sure there's nothing more that we can do. So I started this off with one that was already completely factored. Okay, now if I look at this one over here, it looks like they already factored But I'm looking at this binomial, and can I factor a 2 out of that? So we're not done. So this one here can still take a 2 out. What is left is an x plus 3. Don't forget to bring down your x plus 5. And then before I put my box around it, is there anything more I can do? Nope, that's it. Okay, so give these two a shot. Our last step before we always put a box around it is, can I factor anything more? Okay. Okay, let's see how you did. I got completely factored for the first one, and just like our example up there, I factored a 2 out of the second one. Okay. Now all these things need to come together. If they asked me to check my answer, then I could take 2 times everything in this bracket and then do FOIL times that bracket. Okay, to double check and make sure everything's okay. Boy, that almost looks like a bad word up there, huh? No. Okay, so first step that we're going to do, check for greatest common factor. We're going to look for patterns of different squares or perfect squares. And then if we have a trinomial, we're going to look for, the old x, find my secret numbers, and then we're going to check for common factors. So this is as complicated as it's going to get. So number 1, is it in standard form? Yeah. Number 2, can I factor anything out going all the way across here? I'm seeing that we for sure can pull out a 2. And since that first term is a negative, I want to factor out a negative 2. Can I factor any variables out? Yeah, I can factor out an x as well. So let's see what's left. Now this is where you really have to concentrate. I got a y squared. Then I have a minus 8y's, because a negative times a negative is a positive. So before I go any further, when I'm done here, I want to check and make sure all my signs are right, because it's very frustrating when you start factoring this and you messed up on your signs. So negative pi, that one's good, that one's good, and that one's good. Now, can I factor this guy? So I want to come over here and make an x, and I want to say, okay, I need 2 numbers that multiply to 16 but add up to a negative 8. Is there anything there? Well, yeah, we could do 4 and 4, and both of them have to be a negative, don't they? Uh-oh, that was a perfect square, wasn't it? That's okay. So watch what happens here. I just say y minus 4 and a y minus 4. That was a perfect square right there. I didn't recognize that. So now I'm going to go down to my final answer, minus 2x, and we got a y minus 4, and they're both the same, so I'm going to say squared. Okay? Should have checked for that perfect square thing. All right. Did we have 2 of them up here? Did I miss one? Nope. We're just going right down here. All right. Try these 2 real quick, and we'll see what you did. All right. So let's see how we did here. I factored a 4. I'm going to put parentheses around these guys. Factored out a 4x. And then we had a perfect square there. Looks like I didn't recognize that again. Over here, I factored out a 2y. And then look at here, I had the difference of a square. I had an x squared, and then I had a minus. So if one was a plus and one was a minus, my middle term goes away. And so there's my final answer on 2b. Okay. All right. So, steps here again, factoring completely. Is there anything I can take out all the way across? Nothing. So then the next step is, let's factor this thing because I have a trinomial. So, 2 times 4 is 8. And my middle term is a 5. Is there a way I can get an 8 by multiplying and a 5 by adding? I did 4 and 2, that would be 8, but I can't get a 5. If I did an 8 and 1, that one. So I don't see any combination here. So this one is completely factored. Let's go over and look at this one. Is there anything I can take out all the way across? They're in order, degree of 4, degree of 2, 3, and degree of 2, but I can take a 3 out. So let's take a 3 out. I got n's in all of them, so I can take at least one n. My smallest exponent is a 2. So now let's see what's left. Going over here. Okay, so now let's see if we can factor this guy. Some of us are really good at this factoring thing here and already know on a nice simple problem like this that I need to multiply to a 4 but add up to a 5. And so we could say 4 and 1, right? And I need them both to be a negative. Now, if we just took a jump there, because you aren't there yet, well, just do what we've been doing. I need two numbers that multiply to 4, but add up to a negative 5. And if you said 4 and 1, and they both had to be negative, they add up to a negative 5. Now, nothing else I can do. Okay, so put a box around it. Anything going across that I can take out? Well, yeah, I can at least take a 2 out. Can I take a 4 out? No, just a 2. So let's factor out a 2. Can I take any x's out? Yes, I can take at least one x. What is left? We got 2x squared plus 9x plus 10. Let's go and factor that now. I'll make my thing over here. 2 times 10 is 20, so I need two numbers that multiply to a 20, but add up to a 9. How about 4 and 5? That'll work. So 2x squared plus 4x. Now, the way you factor your trinomial, I don't care what way you do. This is the way I've been lucky enough to have that kid show me. And so it's just what I go to automatically. So I can factor out of my first half a 2x. What's left? Okay. I have an x plus 2. So I'm going to write that over here. So now, don't forget this guy up here. Okay. So we have a 2x. Now when I get my factors down here, these two guys go together in one parenthesis, 2x plus 5. And then I want to bring down one of those x plus 2's. Now before I go on, make sure there's nothing else you can do. And I like it. Whenever I get one like this, I know that they're kind of probably going to be something like a perfect square, because I can pull out a p, and that leaves me with a p to the 4th minus 1. Now, remember, if I had a p squared and a p squared, and I want my middle terms to go away, one of these guys has to be a plus and one has to be a minus. And now I have a p. Don't be fooled by this one. Before you run that and say, hey, that's all done, how about this guy again? Because again, I got a minus 1 here, so can I factor this guy into a p and a p? And here say plus 1, minus 1 again. Again, if I have a plus 1 and a minus 1, last term is going to be a minus 1. And I'd have a plus 1p and a minus 1p as my middle terms, and they would cancel out. So now I'm going to bring everything straight down that I didn't use because they're still a factor. And so now that was kind of a tricky one there. We're going to look for perfect squares or difference of a square. Okay. All right. So now that one's completely factored. Don't look at that. All right. I did it in the wrong order there, and I wasn't going to rework all my work. So do these four, and then let's kind of see how you did. All right. So here's what I got for the first one. 3x plus 4 times x plus 1. 2p to the third times p plus 6 times p minus 1. 3q to the 4th times 3q plus 2 times q plus 2. We call that the quantity of 3q plus 2 and quantity of q plus 2. So if we say the quantity, that means there's parentheses. This one here I thought might be a perfect square, but the only way I can get my middle two terms to cancel out is if one's a positive and a negative. So because they had a plus sign here, I couldn't think of a way that I could still factor that out and still get back to it. All right, so today, these are the steps that we want to look for. We want to first look for if is it in order, and then we want to look for common factors all the way across. If it's a binomial, we're going to look for differences of two squares, or is it a perfect square? If it's a trinomial, we're going to look for the two magic numbers and factoring it however best you like. The slide and divide or the lazy method, the lazy AC method, whichever one you like. And then if we have 4 or more in our terms in our deal, we're going to look for factor by grouping. Okay, so these are all the things that we've learned, and now we should be really good at. All right. So when you get to the practice sheet today, we're going to kind of look at these things and say, hey, is it completely factored or not? Just be really careful. And if it's completely factored, then you just write that. And if it's not, well, then you factor some more and factor everything out that you can. Okay, so today it takes a lot of thinking. Okay, all right, so these, and then tomorrow we'll see what we got in store here. I'm having a meeting with the other teachers today, but it looks like we're going to do the review tomorrow. Tomorrow's Wednesday already, so we're going to give you a test review, and then on Thursday we're going to let you get a good start on the test. And then Friday, there's a dance, I think, and so we don't want any homework. And so if you didn't finish the test on Thursday, we're going to let you wrap it up on Friday because it is a little bit longer test, okay? All right. Hope you're feeling better and hope to see you back in school soon. Thanks for keeping up on all these assignments.